Hello everyone, welcome back to DDL's PackReview series. My name is Peter Johnson and I'm here today with Scott Levy, and today we're going to talk to you a little bit about accelerated aging, particularly based off the ASTM-F1980 standard. What is accelerated aging?
Accelerated aging is nothing more than an artificial process by taking packaged products and putting them into a chamber, elevating the test temperature to claim a specific expiration date for a medical device product and or package. The ASTM-F1980 standard is primarily meant for sterile medical packaging, but a lot of companies and organizations use that as well to claim specific expiration dating for products. If you take a look at elevating that test temperature, for example, let's say you want a 1-year expiration date and you choose a temperature of 55°C, you can get to the market basically in 38 days or 40 days depending upon that ambient temperature.
What is the primary place that you would see medical device manufacturers use accelerated aging?
Well, primarily they'll use it in their package validations. You know, to be in compliance with ISO 11607, you need to claim that specific expiration date on your sterile medical package. So primarily in package validations. Again though, a lot of medical device manufacturers will utilize this just for their product aging. So for example, they want a 1-year expiration date on their product, they want to see what the overall functionality would be. So they'd elevate that test temperature to a place where the product is not going to be adversely affected and then do their product testing.
So how does accelerated aging work? What's the science behind it?
Well, the science behind it, ironically enough, alright, so ASTM-F1980 is the actual document, but the theory itself is known as the Q10 theory. For every 10 degree increase, it doubles the reaction rate of the materials. That entire formula and that Q10 factor came from the food industry. And I get the question a lot, well, is this an exact science? And by no means it's not an exact science. But when we're running accelerated aging, I kind of express this to my customers as this is a gift given by the FDA as well as the governing bodies. They allow you to utilize the Q10 theory or ASTM-F1980 to get your products to market faster. But it's also critically important to understand that you also need to follow this up with real-time aging. If you don't follow it up with real-time aging, you don't have conclusive evidence that you're not going to have issues with your packaging system or your product over the course of that specific shelf life.
So can you pick just any temperature that you want for the accelerated aging temperature?
You got to remember that accelerated aging is a very conservative estimate, all right? So the key thing before you pick any test temperature is understanding your VICAT softening point or your glass transition rate of all the specific materials that encapsulate your medical device and or your medical device packaging system, meaning polytypic pouch, trays, etc. You need to understand where that softening or melting point is before you can pick a test temperature that's going to work properly. Now the Q10 theory that's in ASTM-F1980 is meant for homogeneous materials. And I think a lot of people lose track of that because homogeneous is a single material, all right? So you got to remember that the reaction rates are different for 1 material, 2 materials, 3 materials. So what you're really trying to understand with your packaging system is to find your weakest link. What is the test temperature that's going to adversely affect all of my materials? Once you find that specific material and the test temperature, that's what you're going to age your samples at. I get the question a lot, Scott, why don't we just jack up the temperature to 65 or 70 or 75°C? You know, let's get this done as quickly as possible. And I agree, why don't we just do that so we can get aging done fast so Mr. Customer can get to market as quickly as possible. But the problem with that is the test temperature over 60°C, it's not a linear function anymore, meaning you get above 60°C and the reaction rates are different. You start dealing with kinetic modeling of materials, it gets down to a very complex and scientific aspect. The industry as a whole has gravitated to a conservative factor. The most typical test temperatures are 50, 55, and 60. If you look at the standard and the Q10 theory very closely, the true conservative factor is at 50°C. Now over the years, everybody's moved that test temperature up to try to speed them up or speed the process up to getting the products to market faster. But I myself would counsel you not to go over 60°C, and the standard counsels you not to go over 60°C. You got to remember, for accelerated aging and all the different products and the materials, you're only as strong as your weakest link. and you need to find out what the weakest link is in your product material so you don't end up with problems. When I started over 20 years ago, I had a customer ask to put PET G trays in a chamber at 75C. I didn't know any different back then. So we did that, and I put it in on a Friday, and on a Monday I came back to sludge in the bottom of the chamber. So that was probably the key and critical element in my career to understand, listen, you need to understand what the softening point is of every specific material before you can put it in that aging chamber at an elevated temperature. Products, on the other hand, are a little bit unique. You got to remember that F1980 is meant for packaging materials. Product aging is a whole different aspect because there's no set guidelines for product aging. Everybody gravitates to F1980 for that, but again, if you put, let's say, a product, my pen here, at 75 degrees Celsius, and your expiration date is 4 days or whatever that's going to be, and then I'm a regulatory body asking you to justify how you did this and why you did this, you have to have good reasoning behind it. So again, I counsel, even for products and packaging, not to go over that 60C threshold.
Thanks everyone for joining in. As a reminder, you can visit our website for more PackReview series at www.testedimproving.com.